Example for 5.11. Sulfur dioxide is a molecular substance and is formed by the bonding of a sulfur atom to two oxygen atoms. The molecular formula is SO2. So I want to draw the Lewis electron dot diagram for this. So in this formula, there's one sulfur and there are two oxygens. So I need to find out the number of valence electrons present in this molecule. What I'm going to do is I'm going to go to the periodic table and find oxygen and sulfur on the table. Notice that both of these atoms are in group 6A, meaning they have 6 valence electrons. Looking at my simplified periodic table, you'll see that, once again, oxygen and sulfur are in the 6th column over. In group 6A, they have 6 valence electrons. So we've got a sulfur atom and two oxygen atoms. The sulfur atom brings 6 valence electrons to the table for bonding, so to speak, and the oxygen also brings 6 valence electrons to the table for bonding. So, going back to the problem, I'm drawing the Lewis electron dot diagram for sulfur dioxide. So for the sulfur, each sulfur has 6 valence electrons, so that's 1 times 6. Each oxygen has 6 valence electrons, so that's 2 times 6. 6 and 2 is, 2 times 6 is 12. 6 and 12 is 18. So there are 18 valence electrons to distribute. Now, the central atom is the sulfur, because that's the atom that's appearing first in the formula. So I'm going to put the sulfur down as the central atom, and I'm going to put the two oxygens down outside of that central atom. I'm going to connect the central atom to the outside atoms with a single line representing the sharing of a pair of electrons. And just to emphasize that, I'm going to put a pair of dots on that line, a pair of dots on the other line. So now each oxygen sees 2 electrons. The oxygens obey the octet rule. They want 8 electrons, so each oxygen needs 6 more electrons. All right, now each oxygen sees 8 electrons, and the sulfur, however, only sees 4 electrons. It wants to have 8 around it, so you have to give it 4 more. Okay, well, let's just see what's going on here. So how many electron dots do I have in my diagram? I got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I've got 20 electron dots here. Well, that can't be right. I only have 18 valence electrons to distribute. So what I've drawn here is incorrect. Yeah, think of it as a trial structure. So I'm going to scratch that out, and I'm going to draw another structure. Now here's the trick. There's 2 electrons too many in my trial structure. I'm only supposed to have 18, but I had 20. The way you eat up 2 electrons is by adding another bond called a double bond. Here, I'll show you what I mean. So I'm going to draw my structure again. Here's the sulfur. Here's an oxygen and another oxygen. And it doesn't matter which oxygen you stick the extra bond on. Start out there. Okay, so got a single bond between the sulfur and one of the oxygens, and a single bond between the central atom, sulfur, and another oxygen. Just arbitrarily, it doesn't matter which oxygen you choose. I'm going to put another bond there. Well, I'm going to put dots on the bond because if you recall, as a bond is the sharing of a pair of electrons, and in this case, we've got 2 bonds between the sulfur and the oxygen, and here we have 1 bond. All right, so how many electrons does this oxygen see? Well, this oxygen sees 4 electrons, wants 8, so it needs 4 more. This oxygen sees 2 electrons, wants 8, so it needs 6 more. How many electrons does the sulfur see? Well, the sulfur sees 2, 4, 6 electrons. It wants 8, so you have to give it 2 more, so make 8. How many dots do I have down? 2, 4, 6, 8, 10, 12, 14, 16, 18. And so now, since we have 18 valence electrons, we have a happy Lewis electron dot diagram.